Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl, like Kid Calculus and the Daring Derivative.
Counted on our fingers and toes.
Okay, we're on 19D, 6 through 8. Dan left Atlanta heading for Tampa. Then Chris left Tampa heading for Atlanta. Alright, I'm going to stop right there. Okay? So here, let's just say we have, here is Atlanta, and here is Tampa. So we had Dan leaving and he was heading for Tampa, and then Chris left Tampa and was heading for Atlanta. So now we're going to have this scenario to where two people leave in the opposite places and they are heading towards each other, and they will meet somewhere. I'm not going to say in the middle, but they're going to meet somewhere in between. Okay? So here we're going to have a distance for Dan. So that D represents Dan's distance. And here we're going to have a distance for Chris. So these two together, these distances, Dan's distance plus Chris's distance, will be the total distance. So let's go back to the problem. So it says they were each heading, one was headed for Tampa and one was headed for Atlanta, and they were 400 miles away. So the two cities are 400 miles apart. So we know that Dan's distance plus Chris's distance is 400 miles. Alright, now let's go back to our information. So we can write out information for Dan and write out information for Chris. So then it said Dan left at 7 a.m. Okay, so he left at 7 a.m. And then, okay, so it turns out I didn't have the whole problem written on the board. So here's the information that we were given in the problem. Dan left at 7 a.m. and we want to know what time did he arrive, or we want to know how long did he travel for, okay? How long did he travel and what time did he get there? Then the problem also gave us the information that Chris's rate is 60 miles an hour and he left at 8 a.m. So we want to know what is his time, how long did he travel, and then what time did he get there. So the problem also told us that Dan traveled 5 miles an hour slower than Chris. So if Dan traveled 5 miles an hour slower than Chris, that means that Dan's rate is going to be 55 miles an hour. Okay, so if we have the Dan's distance plus Chris's distance is 400 miles, and everything was in miles and hours, so all my units should be good. I can replace Dan's distance with his rate and his time, rate times time, plus Chris's rate times his time. So out of the information given, we knew Dan's rate, we knew Chris's rate. We did not know their times, but we knew what time they left. So this means that we need to have another equation because we have two unknowns, so we need to have another equation. So we can write an equation for the time. We know that Dan left at 7 a.m. and Chris left at 8 a.m. So Chris left 1 hour later, which means Dan will travel 1 hour longer because he left earlier. True? So if Dan's time is longer, we could make this statement. We could say that Dan's time is Chris's time plus 1 hour. Okay? Whatever equation you decide to write, because if you notice, if we subtract 1 to the other side, we could write this that Dan's time minus 1 is Chris's time. Either one of those is acceptable. They're both the same thing. The main thing you have to make sure is that Dan's time is longer. He left an hour earlier, so he's going to be traveling 1 hour longer. So Dan's time is Chris's time plus the 1 hour that he left earlier. Okay, so you have to make sure that this equation that you write makes sense with the information that they give you. Alright, so now we can use substitution. If we use this equation, we can take this because Dan's time equals this, and we can substitute it in right there. Because then we'll have our two equations and two unknowns. So we'll go back to here. So Dan's rate was 55 miles an hour. And then his time, we're going to substitute that above. And then Chris's rate was 60. And then we don't know his time. And that was equal to 400. Okay, so now we can distribute that. So 55 TC plus 55 plus 60 TC. Okay, we can combine our like terms. We can combine our TCs. 55 of these plus 60 of these is 115 of these plus 55. And subtract our 55 to both sides. So 400 minus 55 is 345. Divide both sides by 115. And Chris's time is going to be 3 hours. Because this one says, how long did it take? His time. So if it took Chris 3 hours, how long did it take Dan? Remember, it took Dan 1 more hour longer because he left an hour earlier. So then Dan's time should be 4 hours. That's how long it took him. But then the problem also asked, what time did they meet? Okay, so I need you to go back up to here. So what time did they meet? If Dan left at 7 a.m. and he traveled for 4 hours, what time is it when they meet? 4 hours from 7 a.m. should be 11 a.m. Okay, if I want to go check it with Chris's, if Chris left at 8 a.m., and we said Chris traveled for 3 hours, well, 3 hours from 8 is also 11 a.m. So they met at 11 a.m. That was another one of your answers. Okay, we're looking at 19D, 9 through 11. Sue and Carolyn were 1,031 miles apart. Sue left South Bend heading east at 5:30. 2 hours later, Carolyn left Boston heading west at 51 miles an hour. They are both heading in the opposite, well, I should say opposite direction. Okay, you have Sue, who's here, and she's heading east. Okay, that's east. Okay, here's Sue. And then you have Carolyn over here who's heading west. So there's Carolyn. She's heading west. So this is one of those scenarios that they're going to meet somewhere in between. Okay, and then it said that they were 1,031 miles apart. Okay, then it said Sue left at 5:30 a.m. So I'm just going to write this information right over here with her. And then 2 hours later, Carolyn left. So if Sue left at 5:30 and Carolyn left 2 hours later, that means she left at 7:30 a.m. because that's 2 hours later. And then it said Carolyn was going 51 miles an hour. So the rate of Carolyn is 51 miles an hour. And then Sue traveled 1 mile an hour faster. If Carolyn was going 51, that means that Sue was going 52 miles an hour. Okay, that's the rate of Sue. How long did each drive and when did they meet? So here we have the distance of Sue and the distance of Carolyn. So we can make the statement that Sue's distance plus Carolyn's distance is 1,031 miles. We can replace her distance, Sue's distance, with the rate times time. And then we can replace Carolyn's distance with a rate times time. Okay, from the information for the problem, we know Sue's rate, we know Carolyn's rate. We don't know their times, but we do know when they left. So since we have two unknowns, we have to have another equation. So if we have two unknowns, we have to have two equations. We know that Sue left at 5:30 and Carolyn left at 7:30 in the morning. So Sue left 2 hours earlier, which means her travel time should be longer, okay? Because they're going to meet at the same time. So it means Sue traveled 2 hours longer since she left earlier. So we could say that Sue's time is equal to Carolyn's time plus 2 hours. This shows that Sue did travel 2 hours longer than Carolyn because she left earlier. Okay, now that we have that equation, we can take this and then use substitution. TS is this, so we can replace that right there. So now let's fill in what we know. We know Sue's rate is 52. We're going to use substitution for that. Plus Carolyn's rate is 51. Everything was in miles and hours. Make sure all my units are good. And then we don't know Carolyn's time, so we leave that. Now the only unknown we have is TC, and that's good. We only want to be left with one unknown. So we can distribute that. 52 times 2, 104, plus 51 TC equals 1,031. Combine our same kind, 52 of these plus 51 of these is 103 of these. We can subtract our 104 to the other side. Okay, 1,031 minus 104 is 927. Divide both sides by 103. So, how long it took Carolyn, remember this is not her, this is the time that it took her, not the time she left, but the time, how many hours. And that came out to 9 hours. So, Carolyn traveled for 9 hours. Remember from our formula up above, Sue traveled 2 hours longer. So, if Carolyn traveled for 9 hours, Sue traveled 2 hours longer, so that would have been 11 hours. It took Sue because she left 2 hours earlier. Now to figure out what time that they met, so we said here that Sue left at 5:30 in the morning and she traveled for 11 hours. Well, I know 12 hours would be 5:30 p.m., so 11 hours would be 4:30. Should be 4:30 p.m. And then if we check it the other way, Carolyn left at 7:30 in the morning and she traveled for 9 hours. So 9 hours to here, 9 hours from 7:30 in the morning should still be 4:30 p.m. So what time do they meet? 4:30.